Hopefully you're hearing me. If not, please let me know. What is going on here? Okay. So, um, we've already. I'm going to put some text up. Actually, can someone let me know if the audio is up? Because this mute issue on. Okay, that's good. So, we've already completed Lab 16 for the week. So today I'm happy to answer project questions. I'm happy to answer final lab questions. I've got, you can see my browser, so I've already got Replit up and ready to go if anyone wants to do that. Sorry, you're looking at junk from another class, so um, I can sort of work with you on anything that you would like. So just let me know. What you'd like to do. And I will. If you have lab questions, of course you can ask them. Um, the one thing I will remind you of, so please don't forget that the last day of the semester is May 29th, so that's the last day to turn in anything is May 29th. But otherwise, no new content. Okay, that works for me. Let me get my Replit in a nicer location here. One thing to notice, by the way, about I'll put it in chat, but in REPL, it um, life is a lot easier in Replit if you just for this is not really related, but you're gonna see me create a couple of new REPLs, and that's just to point out that it works a lot better if you go to a new lab or you go to a new project or a new assignment. It's easier if you just create a new REPL for it, and then just name the REPL um, so that you remember what's in there, because you can't put multiple um, projects inside of a REPL. So I'm going to make a new one. Um, and I'm just gonna let me make sure that you are seeing. Okay, you're not. Okay, so there's my new REPL, and I'm gonna make it a lot bigger. Actually, I'll just sort of fill this whole side of the screen with it. Ooh, that's challenging. Um, uh, we could try that out. Tic-tac-toe is actually harder than it seems, but we can try it out. Um, actually, we can do. Uh, yeah, we'll think of something. So anyway, I created a new REPL, and I'm doing this to show you. Um, I think if you click this edit right here, so REPL it makes funny names for your REPLs, but um, yeah, so you can rename your REPLs. So I could call this like a 21 May 20 examples, and that way I don't really need um, a description. But anyway, now when I go back to my dashboard in Replit, the title of the REPL is easy for it's easy for me to remember what it was I was doing. The other thing that I've done, just to show you, notice how I have it stacked. So if you go to the settings over here, this gear, if you go to the settings, you can change the theme and stuff. So there's a light theme and a dark theme. I like the light theme better, but you can also change the layout. So you can change it from side by side to stacked, and I'm just sort of experimenting with stacked. Nothing else really needs to be done, but just to point that out to you. Okay, so let me think. What can we do here? Well, let's just actually, if you're okay, maybe we'll make a vending machine in C++ if that's all right. I mean, it's not the most exciting thing, but I can show you lots of different features of the language if we do that. So I like to I put this using directive up here using namespace std, and when you do that, uh, yeah, and then you'll actually sort of so Tyler, I'm going to steal your basically I'm going to steal your project, your logic, and do it in C++. So see this std : here. So that stands for, that means standard. And namespaces are just a way that the C++ language organizes its libraries. So, for example, in Go you have import fumped, and in Go there's really only one layering of organization, but in C++ there's two layers of organization. So this first line is kind of like an import, but in C++ there's actually a second layer of organization called namespaces. And we could get sidetracked by that, but I'm just pointing out to you that there's multiple ways to deal with this extra layer. The easiest way is to put this using, we call it a using directive, and then everywhere where you see std : that can just go away now, and it just makes the code easier to read. Okay, so let's do a vending machine program, and I'll put functions and I'll put some other stuff in here. So struct item. So you can do structs in C++. We've looked at a class as an example as well, but you can also do structs. In C++, if you see class or struct, they're very, very similar. In fact, they're so similar that it seems dumb that they're both there sometimes. But I'm going to use a struct to make this sort of feel as much as possible like C++. And then inside of here, we're going to have a name. Let's see, what else do we have? We had a price, which, so where we would have put float 64 in the Go language, we're going to use double. That's what float 64 is in C++, basically. String, by the way, needs another include. You don't have to do that in Go, but for strings in C++ you do. That may not be big enough. Get rid of these settings. And let me look at my screen and see if that, hopefully that's plenty big enough. Double price, and then we have the int quantity, and then int purchased. And I'm just going to push this down a little bit to get it out of the way for a second. Okay, so one thing to note here is that in Go we do the variable name first, followed by the data type, and in C++ it's the data type first, followed by the variable name. Not that big a deal, but it is different. C++ uses a lot of semicolons, so you won't like this if you're coming from Go at first, that there's all these extra symbols you got to type. It's one of the things, Go being a newer and more modern language, has sort of gotten rid of some of this garbage. But there's the same struct. Like this is the one that Tyler used in his project, which is similar to one we talked about during a lecture at some point. Another thing to note, well, no, let's not worry about that. So good start. Okay, so now I'm going to write a function to create items. And first, I am going to show what it would look like in Go, and then I'm going to translate it. So in Go, we do this. Well, close to it, right? Name, string, price, float, 64, quantity, int, and we'd have it return uh, an item like this. So this is what the go function would look like. I'm just showing you that so that I can get rid of it and do a C++ one in its place. So we're going to write that in C++ just so we can compare them. Um, so there's the C++ one. Um, so in Go, every function says func on the front of it, but in C++, you actually take what the function returns and you put it first. So item here is what the function returns. Now I'm not doing a star in this case because the C++ handles this part just a little bit different, but you will soon enough see something familiar. Anyway, so there's the return. So the new item function returns an item, as opposed to in Go where we say the function new item returns an item. The parameters are pretty close to the same, but again, notice that the data type comes first. But we still are going to return. How do I want to do this? Let's say I think that works. We'll find out when I run it against the compiler here in just a little bit. So there's that same function, and notice that the syntax is a little bit different for putting it together, although it's similar. Um, and then I return the item. So it returns same idea. So you can see the differences. I don't have a star item uh, because there's a slightly easier way. I can do this in C++, but it's more awkward than in Go. So in C++ is actually easier to face the awkward bit later. So there's a new item. Let's see if we can build one. So for starters, let's just say item soda equals new item soda. I don't know, 75 cents. Let's say we have 10 of them. And then I hard coded the purchased amount just as a 0 in here. We'll just assume that by default they haven't purchased any. So hopefully that, and hopefully it works, but hopefully that kind of looks familiar to in comparison to what we've been doing in Go. Let's make sure it runs. Okay, so it ran, it's fine. So let's put these in. So we're going to say so we call this an array. So in C++, there is something called a vector, but we're going to use an array in this case. Do I want to do that? Sure, it doesn't really matter. So kind of the same thing, but notice here that the way we say an array or a slice of item is a little bit different. But again, pretty similar. So let's put some items in there. I want to change that. No, no, no. Let's keep it simple. Let's keep it simple. So to chips, I'll charge $1.25 for those. Just say we have like 3 bags of chips left. Put some water in there. Make that be 99 cents. 7. I'm just doing different quantities. So the chips candy. Let's make that expensive to discourage people being irresponsible. And they're not buying as much because it's expensive. And then I'll have like gum. Just say 25 cents, and I have like 5 sticks of gum in there, something like that. I don't know if we need that comma in C++, but again, it's similar, right? I mean, you kind of have to get used to where the differences are. I'm just going to press run to make sure that I don't get an error. I do. Yeah, it wants this over here, I think. Yeah. Okay, so notice I had to put the square brackets on the other side of items. Okay, so hopefully still kind of looking a little bit familiar. Um, let's see, we also wanted to describe them, right? So, okay, now let's set up our little, yeah, we can do that. Let's see, how do we want to do this? Let's do the menuing thing first. So, I'm going to have a bool shopping equals true. So one thing to note about C++ is that most strings are a little bit different, but generally you should assume in C++ that nothing is ever in its zero state. You don't get that for free in C++. So when you declare an integer variable, you have to give it an initial value, say of 0. If you don't, you get sort of garbage values in there. So you'll see C++ programmers doing a lot more assigning initial values to things than they would in Go necessarily. And then while shopping. I don't want to go too far up here. So we don't have a while loop in Go. We only have for loops, and in C++ we have a bunch of different loops. So this is the same thing as saying we'd say for shopping, or for shopping equals true. In C++ we can say while shopping, which is the same thing as saying while shopping is true. But most of us will not say the implied equals true part just because it makes sense while you're shopping. I'm going to keep showing you stuff. So let's do it this way. Now let's add a few more functions. So we will do a function to display items, and then I'm going to pass my items array in this case. Now in C++, at least the way I'm set up, I actually need to say how many items are in there. That doesn't come for free. There is a way to get it for free if we did a slightly more elaborate thing here, but I'm putting that 5 in there because the function needs to know how many items there are, or will need to know it. So that's going to be my items. Clearing screen is harder in C++ than in Go. So let's display the items. Okay, so I'm going to do it in Go again, and then I'll switch it to C++ so you can compare. So this is what we do in Go. And this is a function that doesn't actually return anything, just receives a slice of item and would loop it. So the comparable thing in C++, when you see void, that means that in C++ it doesn't return anything. So no return value, just does work. Display items, and then item, I always get confused about this part, we'll see. where those square brackets go. And then sort of the classic style in C++ is that you also have to, when you pass an array like this, you also have to pass how big it is separately. That's sort of the classic style in C++. There is a more modern way to get rid of that, but we're just going to do it in sort of the old school way. Okay, so there's and then what we're going to do here is we're going to do for int I equals 0, which should look familiar except for the extra parentheses. So this is a counting loop. I less than num items. So notice we're using num items here instead of the length of the slice. I plus plus. And then we will do items at I dot describe, so we can show that similar kind of thing to the Go language. So we're going to take each item and then call an item method on it to describe it. We're going to need to know its number, aren't we, to show it. The number. So I'm going to put, how do I want to do that? Yeah, let's add the number here. No, I don't like that. Don't do that. We don't really need that, but we do need to have a number here, so I'm just going to say I plus 1. So I'm just going to use the index of the item as its number when I describe it. Okay, so we're setting up, this is a method call, and so now you sort of have to watch carefully because this is going to look different. So I'm going to go up to my struct. In C++, the way you write methods is that you put them inside the struct. So in Go, they're separate from the struct. In C++, you put them inside the struct. Describe is a void function, and then it takes a number in here. So methods go inside the struct. Whereas in Go, we'd put them outside the struct and we'd do a little like I star item thing in front of it. Okay, so now we're going to do, and again I'm sort of doing the classic C++ style. C++ is an old language with lots of stuff in it. But we'll do it sort of the old style. So to describe an item, I'm going to print out its number, probably a dot and a space, and then followed by the name. So Tyler, you might be, I don't know if you've been watching any of the other C++, or I don't actually know who's here. So anyway, for everyone who's here, hello. There is formatted printing in C++, but you really should learn to do outputting the C++ way. So I'll show you what I would do in Go. In Go, I would do this. I would say the number and a dot, and then the name, and then maybe some spaces, and then a dollar sign, and then the price. And then maybe, like in parentheses, I'd say how many are in stock. And then I would have down here like the number, the name, the price, quantity. So that's kind of what I would do it in the Go language, right? So in C++, kind of have to track this, but this cout is the output, that's the console to print to. And then every time I switch sort of content types, I use another one of these. So notice here I'm outputting the number. That's this parameter here. So I output the number. But then I use another one of these because I'm switching to a string in quotes. And then I use another one because I'm switching to the name, which is a string. Um, then I'm switching to using those again because I'm going to put in a few spaces. Then I'm going to put actually with a $sign at the end of it. Then I'm switching again because I'm going to put the price. Then I'm switching again because I'm going to put a space and open the parenthesis. Then I'm switching again and I'm going to output the quantity. So in the Go code, I'm all the way up to there. Now I got to get this in stock bit. Now Go doesn't like this, but C++ doesn't mind. I'm going to, once I get that quantity out, I'm going to go to the next line, and then I'm switching again to space in stock, close, and then switching to put an end line. So that's ENDL, which is end line, or a line break. Pretty crazy. This is hard to look at, but this is one of those things that you get used to pretty quick, so it's good to practice it. You're going to see the price not cooperate with me much at all. Okay, so I'm going to pull this up and I'm going to see if it runs. It did. Now the reason why it's going on forever like that, by the way, which I think I can type Control C down here. Yeah, do Control key and the C key. Control C will kill it. That's because it's in a loop in main and I don't have the loop stopping for anything. Okay, so it's not nearly as pretty looking. I might take out some of the extra spacing. I don't know what to do about that. Let's try, instead of spaces, let's try a tab character right here. So a tab character is \T and see what happens. I'm going to run it again and I'm going to be ready to do Control C because it's going to just run off forever. That didn't really fix anything. I'm just going to go to a space. Okay, so there is a method. We don't call them that, by the way, in C++. We just call everything functions. But I like what Go does is it calls a function a method if it's associated with a struct. And I think that's a good idea. So this is a method, which means it's a function that's associated with the struct and the data of the struct. This number is just a parameter I used to make the menu look right. Okay. Ping me if you think if you need me to hit pause or if I'm going too quick on something. I'm trying to make it look more or less like we would do it in Go, just in the C++ kind of way. Okay, so the reason why it's running forever is because that loop. Yeah. So I anticipated you a little bit there. I got lucky. So anyway, the reason why it was printing forever is because this loop has no way of not doing this. So this does display the item, so that's a plus. I'm going to add a checkout option here, so I'm going to make that option 0. Checkout. You can use \ns for line breaks, just like in Go, or you can use an extra outputter and do an end line instead. Up to you. So that's basically my menu, right? My 5 items display and then my menu. Oh, and then we need a ask them what they want to do. I'm not putting a line break there on purpose, by the way. Okay, so now let's give ourselves an integer to hold their choice. And again, in C++, you don't integers aren't automatically zeroed for you. So you'll see C++ programmers assigning variables when they first create them to zero, or zero to them. Choice. And then here's how you read from the keyboard. So that CN is referring to the standard input. I don't know why I see it, to be honest, but that's the standard input, which on a computer is a keyboard. So what we're really doing here is we are taking input from the standard input. And notice, by the way, the arrows are the other way around. So this direction is printing to the standard output, which is the console, and this is reading from the standard input, which is the keyboard. And then Tyler, I'll show you the same sort of switch trick, but it doesn't look nearly as cool in C++. Okay, so let's do a switch on that. So extra parentheses, just because that's how it works in C++, so we're going to switch on the choice. And then let's do, all right, so something to note here. In C++, when you set up a case in a switch, you have to put a break at the end of it. Go does not require this, but C++ does. So every one of your separate cases has to have a break at the end, which is how C++ knows where that section ends. In Go, it knows the section ends when it sees another case. So this is all the sections. We got the 0 section, and then just like in Go, we have a default. And in this case, we'll probably say, and it's safe to put a break here too. So the default would be they didn't pick 1, 2, 3, 4, 5, or 0. So we'll say we'll just tell them that wasn't a valid choice. CN Reader is associated with it, yeah. So, we could use CN Reader. If there's one in the challenges, we'll put it in here. That would be neat. So yes, CN Reader is code that I wrote to help people with this CN, because it's actually it's hard to get it working right at a point. So if we have a chance, we'll put that in there. That would be fun to show you how to do that. All right, so hopefully everyone's doing okay. I'm going a little fast. So CN Reader is a library I wrote to help with the CN code segments, because they get complicated. Okay, so what happens in the cases? We're going to need a function to handle a purchase, aren't we? So I would say, how do we want to do that? Well, in case 0, we'll worry about this later, but let's just, for case 0 now, say that they are no longer shopping, and then we'll worry about the checkout stage in a little bit. So shopping equals false will cause the, there's a lot of code going on here. That will cause the while loop to break. So if they do 0, that means they're done shopping. All right, so for case 1, 2, 3, 4, and 5, we want to have them buy some stuff. Okay, so how do I want to handle that? Let's handle it so you can see more functions. So here's what I want to be able to do. I want to say purchase items at 0, the first item. And we might as well just fill that out while we're here. Purchase items at 0. Purchase items at 0. It's not items at 0. Probably you noticed. That's items at 1, items at 2. items at 3, items at 4. So we're going to write a function that handles the purchasing of an item. And then I'm just sort of hitting pause a little bit because I don't want to badly overwhelm. Okay, so notice this is not a method. It doesn't say items dot something. It's just purchase. So we're going to do this sort of in 2 phases. And again, it's in part so I can show you more functions and more methods. Okay, so now you're going to see something a little bit weird, but you will be familiar with the point of it. So purchase, and what we're passing is an item. I'll just call it I. So I didn't do the Go version of this, but it's a non-returning function that takes an item. Now here's the thing it's going to feel backwards. But what I can do as my function is I can actually put the ampersand here, and what that allows me to do is make edits to this item. So in Go, we tend to work from the other direction. I create an editable item, and then I can pass it to functions and let those functions edit it. In C++, I can literally turn the item into something editable in the receiving function. Good or bad, you can decide. Not everyone thinks that's a good idea, but you can do it. So I actually, by putting that ampersand there, this item is now editable in the function. So let's see, again, I'm kind of stealing from, not kind of, I'm stealing from Tyler's project, who we were reading through it yesterday. First thing we did was, so let's just use an if. If the i's quantity is 0, it's sold out, right? So I is an item and item is a struct, and we can use the dot notation just like we would in Go. Notice on the if, by the way, that the expression has parentheses around it. I love it that Go took those away, but C++ did not, so extra parentheses there. But the logic still, when they try to purchase an item, I'm just going to check to make sure that there is any of that item. And if it's 0, then I'm going to say I.name. So notice here's the output. And then we call this the insertion operator. But anyway, outputting the item's name. And then I am switching to a string where I will say sold out. And then I am switching to the end line. Okay, else they can buy some. So let's see, how do we want to do this? I think what I want to do, I think I'm just going to let them buy one at a time. I'm not going to say how many or any of that stuff. We're just going to buy one at a time. So now we're going to use a method. So we're going to say, no we don't. No, we don't need to do that. Let's just edit it. So we're going to purchase one, semicolon. Just got to get used to that and Go. We're going to purchase one. We're going to back off its quantity one. So I'm not going to let him say I want to buy 5 of them. You just get to buy one at a time, kind of like a machine. So it's either sold out or you're buying one. And when you purchase one, then the quantity of them available to other people goes down, and then I will say, you have purchased. And then notice how I switch. So I'm outputting a string, and then I'm switching to outputting a field. So I.name again, and then switching and putting the end line marker. So it's very important here. The reason I can do these edits on the item is because this ampersand right here. I call that a reference. Okay, so let's see if it runs and see if it lets me buy some stuff. Okay. Oh, I don't know why I put 0 in square brackets. Everybody else has a dot, so I'll fix that. Let me buy a soda. And that's good because soda went down by 1. That's what we wanted. I'm going to buy some chips until they sell out. So now there's 2 in stock, there's 1 in stock, there's 0 in stock. So now when I pick one, now it says chips is sold out. That's what I wanted. Um, okay, so that works except for that looks ugly because I didn't put 0 dot. Where's the 0 dot? Right here. Just to look consistent with the rest of them. Okay, so here's the sort of, Tyler, you'll get this reference, but everybody else, um, when you see yourself repeating code that's so dang close, um, there's just got to be a better way. So you sort of have to think to yourself, well, um, when they chose 1, that becomes item 0, and 2 becomes item 1, and 3 becomes, so choice 3 becomes item 2, choice 4 becomes item 3. This is all 1 less, so I can actually just say choice minus 1 on all of these, right? Now don't type all this because I'm about to make it even less than this code. So, but now they look even more similar because it's literally the same code. Whether or not it's choice 1, 2, 3, or 4, or 5, it's the same code to do the purchase. So in Go, we would do this. This is what I was talking about. In Go, we do this. We can say case 1, 2, 3, 4, or 5, we would purchase items. Um, and then we would just get rid of all of this stuff. But in C++, the way you do this is called stacking the cases. And the trick here is that there's no break statements. So C++, wherever it finds itself coming in at 1, 2, 3, 4, or 5, it just kind of flows until it hits a break. So if it's 2, it's going to hit here, and then it's just going to flow, 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 do a purchase, and then break will be the end of the switch. So that's the way we do that same sort of stacking the cases. Still running the program in C++. It's not the prettiest looking thing, but it is less duplicated code. Okay, so how are we doing? I think we just need to make them pay, don't we? I believe we just got to make them pay at this point. And then do a receipt. Okay, unfortunately I'm getting small. Let me, how much screen real estate do I have to? Yeah, I'm kind of using, I'm going to back off a tick on the font size, and you can tell me if it's gotten too small. Just so I get a little bit more screen real estate to work with. Okay, so the reason why I wanted more screen real estate is because I'm going to go down here. So notice that this is the while loops curly brace. So I'm down here after the while loop for the payment and the receipt. Payment and receipt. So I'll just comment that. So we can do the payment part here. Okay, so I'm going to write a function for this, but what we need to know, and I'm going to do it as a double, so total owed equals, and let's compute total owed from the items. And there are 5 of them. And this again is in part just to force myself to write a function so that you can see more functions in play. Okay, hopefully I'm not going too fast. You guys who have been practicing this for several weeks on Twitch probably gotten pretty good at keeping pace. But it's okay if you need me to go back a step. So let's go do compute total owed, which is supposed to return a double. It takes an array of items and the quantity of things in the array, which is sort of traditional C++ style. Compute total owed. So I'm going to scroll up above main. I'll just do it right here after purchase. So it returns a double, this function, so the return comes first. Compute total owed. Takes an array of items and it just puts the symbols in a weird place. The number of items. Not too different, but different enough that it does take developing some muscle memory about. Okay, so let's see. We're going to need a variable in here called total owed. And again, in C++, you should just zero things out. Now a counting loop.